we discussed AR model and MA model. So now today we are going to discuss ARMA model, AR, MA model, P and Q. So now we can make the model. It looks like this. Here's a phi B, which was the AR operator, and the theta B, which was MA operator. So the ARMA PQ model looks like this. Let me rewrite what was the AR operator. It's a phi B, which was 1 minus phi 1b minus phi 2b square. It's actually the AR parameter was up to p, so it's a phi p bp. It's absolutely the last one is not equal to 0. So it guarantees the p terms in the AR operator. And the other one is the MA operator. It's a theta b was 1 plus theta 1b plus is a linear summation. It's a linear additions. It's a theta 2b square is additionally up to q bq. It's absolutely the last theta q is equal to 0. It's up to guarantee the q terms. So now we just take the multiplication, the phi b, yeah, it was the phi, and this one is a theta, it's a Greek letter. So the phi b xt will be 1 minus phi 1b minus phi 2b square is up to p. It's phi p bp times xt. Then it will be xt from 1 minus phi 1 p times xt is the b was the backshift operator, so the xt will be xt minus 1, and the phi square, and here's a b square, is a backshift twice, so the xt will be xt minus 2, and the last one will be the phi p xt minus p. And the theta part, the right hand side, the theta b times the white noise, I mean here, right? So it will be 1 plus theta 1b plus theta 2b square is up to q times white noise. Then there's a similar one, the very first one from 1 here, it will be just the white noise, and the theta 1, here's a 1 back shift on the time t for the white noise, so it will be w t minus 1, theta 2 w t minus 2, and just to keep going until the w t minus q. So it will be the left hand side, and this one will be on the right hand side. So now I can rewrite the full model, ARMA P and Q. So the very beginning, which was the phi b xt is equal to theta b wt, which is the ARMA PQ. Then this one will be xt minus phi 1 xt minus 1 minus phi 2 xt minus 2 up to phi p xt minus p is equal to wt add phi 1 wt minus 1 phi 2 wt minus 2 is until the theta q w t minus q. And now we can take all of this one, we just add the same thing because here is the negative signs, and we just add the same thing. Then now I can rewrite in the left hand side there is only xt is equal to phi 1 xt minus 1 phi 2 xt minus 2 up to p xt minus p. And then the second term will be the MA terms, the linear summation of the white noise with a theta 1 t minus 1 and theta 2 wt minus 2 is up to theta q wt minus q. So now we have all summations in the right hand side. It's because of that we had subtraction is before in the AR operator, and now we have a AR part. Yeah, it is the AR part, and this one is the MA part. So now we can say it is the AR, MA, P and Q model. So it has two parts. Okay, yeah. So simply, in general, yeah, we can write it's like this way with the AR operator and MA operator. Here's an example. Here's an example 4. Look at this one. Here's a 1 xt minus 1, and here's a wt and wt minus 1. So it's actually, it is the ARMA, it is AR MA. How do you think? How many P? How many Q? You know, we have a 1P here, and 1Q there. So it's the ARMA 1 and 1. I can rewrite. It is the xt minus 0.5 xt minus 1 is equal to, let me put wt first, minus 0.5 is a w is a t minus 1. So you can see, what can I say? Okay, so here's a phi b, the AR operator from here, it must be 1 minus, it's 0.5 b. And from here, as we can say, the MA operator is a theta b will be same as 1 minus 0.5 is a b. So we can rewrite in the form of the phi b xt is equal to theta b wt in this form. Then we can say 1 minus 0.5 b xt will be same as 1 minus 0.5 b again times the wt from here. This one is the topic of the parameter redundancy, and we can reduce the parameter because AR operator, MA operator, they are same. So we just cancel out. So it's actually at the beginning we had ARMA 1 and 1. It looks like this, but it will be exactly same as the model xt is equal to wt. Now I can say it is simply MA1. No, it is not MA1. I'm sorry. It's just white noise. Because the MA1 parameter looks like this one. Here's a theta, right? Yeah. So we need the wt minus 1 term, but it does not have the t minus 1 white noise. So it just is a white noise. So I can say this one, the very beginning, even though it looks like the ARMA 1 and 1, but it is exactly same as just white noise. So we just cancel out the same operators, the AR operator or MA operator. We can make the factoring, then we can cancel out the same operators, the same factors. So we can reduce the parameters and we can make the smaller model. So that is the topic of the parameter as a redundancy.